Alright everybody, welcome to lesson number 7 on symmetry. So for question number 1, they're asking us to identify the following uppercase letters as having line, point, or rotational symmetry. So a couple things to take notice. If something has point symmetry, by default it has rotational symmetry of 180. Okay, so let's look at A. If I draw a vertical line through the middle of A, this has line symmetry. If I turn A upside down, it won't look like A anymore, so it doesn't have point symmetry. And there's no rotation other than 360 that I can use to make A on top of itself, so it just has a line. For B, if I draw a horizontal line through it, this also has line symmetry. Doesn't have point because B would be not the same upside down, and rotational doesn't work either. C also has a horizontal line, so does D. So both of these also have line, so does E. So does M. Now those first 6 letters all have line symmetry, but none of them are the same upside down, and none of them can be rotated any number of degrees to be the same letter again. N is an interesting one because this does not have line symmetry, but it does have rotational symmetry of 180 degrees, meaning it also has point symmetry. Alright, so let's take a look at O. O has line symmetry, both vertical and horizontal, and rotational, and point. So O is one that has all of them. P has none. Z, if I was to take Z and draw a line through it in any direction, it would not come on top of itself, so no line symmetry. If I was to rotate Z, so if I was to take Z and rotate it up, like this point would come all the way up to there, and this point would come all the way down to there, so it would actually have rotational symmetry and point symmetry. Now this might be confusing because it looks like all of the rotationals and points are always the same, but sometimes you will get shapes that have rotational symmetry that do not have point symmetry. We talked about in class like an equilateral triangle or even like a pentagon, right? A pentagon has rotational symmetry, but it does not have point symmetry. So let's take a look at a pentagon. All right. So it says draw lines of symmetry. So pentagon has a vertical line of symmetry through each letter or each vertice. All of the lines of symmetry will intersect at the same point in the middle of your picture. So I'll try and make that work out pretty good. And then each side can also be cut in half as well. So we have this one central location, which is a center of rotational symmetry. So describe all symmetries. So they have line symmetry. This has rotational symmetry. This shape does not have point symmetry. If I was to turn my paper upside down, I would not get back the same picture. How many are rotations? Well, since I have 1, 2, 3, 4, 5 points, I can rotate 5 times. And if I use the rule from class, if I do 360 divided by 5, that gives me 72 degrees. Meaning every 72 degrees, I would get the same exact picture. A would become E, E would become D, and we'd keep rotating around. How many are reflections? So if we look at the lines of reflections that we have, so we have 1, 2, 3. I just want to make sure that we don't get the same ones again. So we have 1, 2, 3, 4, 5. All right, number 3. This was actually a Regents question, which shows a dotted line that is not a line of symmetry. You notice once we start really reviewing for the Regents exam, they like using that, the not part, to kind of confuse you here. So 1 is a line of symmetry, 2 is, and 3 is, 4 is not. If I was to reflect this over, it would look something like this, which would not be the same shape. Number 4 asks how many lines of symmetry does this figure have? So if I start just drawing them in, I have one that's going to connect or cut this in half that direction. I have one that'll connect in half in that direction. And then if I make this line of symmetry, the 2 little circles on the outside will kind of cover, and that line of symmetry. So in total I have 4 lines of symmetry. Number 6 wants us to draw all the lines of symmetry here. So I have one coming down the middle, that'll cut all the shapes in half, and I have one coming across. Even though it didn't ask, this shape also has point symmetry. And the last question, determine the number of minimum degrees of rotation needed to make a regular decagon. Decagons we talked about in class, those have 10 sides. So if I take 360 divided by 10, I get 36 degrees. That's the video on symmetry. Hopefully this helps, and we'll keep going tomorrow with all of our rigid motion work.